Hello children, so welcome to AIMS India's online classes. Today from mathematics subject, rational numbers topic we are going to discuss. So our today's concept is decimal representation of rational numbers. So in our previous videos, we have discussed about all kinds of mathematical operations along with the rational numbers. Today we are going to learn about decimal representation of rational numbers. So all rational numbers can be written in the form of a by b. A by b, or a rational number can be expressed as a decimal by dividing a by b. By dividing a by b. If you see the below examples, here we have 5 by 8, which means we can divide 5 with 8. 5 divided by 8. With this division method, if we divide 5 with 8, 5 is not divisible, 0 we have to take. We have to consider next digit to 5, which is 0. But before 0, we have point here. Point above, point we have to keep. Then it will be 50. Now 8 6 times 48. So while dividing decimals, it's very important, children. Wherever in the dividend part, you are having the point. In the quotient also, exactly at the same place, you have to keep the point. So here 5 is not divisible by 8. We are considering 0, then it will be 50. But before that point is there, so we have to keep point in the quotient. Now 8 6 times 48. 50 minus 48, 2. Now 20. 8 2 times 16. Remainder 4. Next digit 0. 8 5 times 40. So what is the answer? 0.625. So 5 by 8 is a rational number. 0.625 is a decimal number. So a rational number can be represented as decimal number by dividing numerator with denominator. Next children, we have 23 by 16. With 16, we have to divide 23. Means 23 point, as many zeros as we want, we can keep. Here also, only 5 is there. 5 point, all zeros we have written here. For our convenience, we can write like this. After point, number of zeros, as many as we want, we can keep. So 16 1 is 16, 7 is remainder, 7 is not divisible. Next 0 we have to consider, but before that point is there, point to be kept in quotient. Now it is 70, 16 4 times 64, 60, 16 3 times 48, 12, 120, 16 7 times 120, 16 5 times 112, 80, 16 5 times 80, sorry, 16 7 times 112, 80, 16 5 times 80, like this, 1.4375, like this you can write. This already in decimals concept we have learnt the division, children, so that's why I am explaining somewhat fast. Already we have learned this concept. Now 7 by 11. With 11 we have to divide 7, but 7 is small number. So point, as many zeros as we want we can keep. With 11, 7 is not divisible. We have to consider 2 digits. But before 0 we have point. So keep point in the quotient. Now 11 6 times 66, 40. 11 3 times 33, 70. 11 6 times 66, 40. 11 3 times 33. 0.6363. 0.6363. If it is corrected to 2 decimal places, fourth decimal is 3, which is less than 5. We can simply strike it off. Third digit after point is 6, which is greater than 5, which is 6. We can strike off it and we can add plus 1 to the previous digit. So 3 plus 1, it will become 4. So 0.64, correct to 2 decimal places. So in this way, we can represent rational numbers in the form of decimals. So in the first division, 5 divided by 8, the quotient 0.625 is a terminating decimal. Terminating decimal. Here, the final remainder is 0. So it is a terminating decimal. Means the division has stopped. The decimal points stopped. Terminating decimal. Whereas in the division 7 by 11, the quotient, in the division 7 by 11, third one, the division, the remainder is not 0 and the same process is continuing. So 70, 40, 70, 40, again 70, 40. If you go on dividing like this 70, 40, 70, 40, this 6363 part will be repeating. Means it is not at all terminating, but repeating. So this the division by 7 by 11, 0.6363 and so on is a non-terminating decimal. Means the division part never terminates, and the remainders 4 and 7 keep appearing. Remainder 0 never reached, and 0.6363 and so on. This the digit 63 after the decimal point are repeating. So it's an example of non-terminating repeating decimal. Okay. So after division, based on the decimal which we have got, based on that we can name the decimals into different types. Terminating decimal, non-terminating decimal, sometimes repeating decimal. So decimal representation of negative rational numbers. So we have to find decimal representation of minus 5 by 4, but it will be same as decimal representation of 5 by 4, which is prefixed with a minus sign. If decimal representation of 5 by 4 is 1.25, then for minus 5 by 4 also 1.25 only. But as we have minus here, this decimal number should be prefixed with minus sign. That's all. No other change is required. Next. Insertion of rational numbers between two given rational numbers. Between two given rational numbers. So on the number line, we have 0, 1, 2, minus 1, minus 2, minus 3, minus 4, minus 5, which are separated by unit distance. Here 2, 3, 4 are whole numbers between 1 and 5. Between 1 and 5, write insert whole numbers between 1 and 5 means we can insert 2, 3, 4 between 1 and 5. Or insert integers between minus 5, 2. Minus 5, 2 means minus 4, minus 3, minus 2, minus 1, 0, 1. These integers we can insert. These integers we can insert. And one more thing, between 0 and 1, there will be no whole number. Or between 1 and 2, there will be no whole number. Between two whole numbers, between two consecutive whole numbers, there will be no other whole number. Or between two consecutive immediate, two consecutive integers, there will be no other integer. No other integer. But rational numbers case is different. It's not like whole numbers, not like integers. Between two rational numbers, 1 by 2 and 3 by 4, we can insert infinite Infinite means unlimited, countless, infinite number of rational numbers. So between any two given rational numbers, we can insert infinite number of rational numbers, unlike whole numbers and integers. That process we are going to learn now. So let's take two rational numbers, minus 1 by 2 and minus 1 by 5. Minus 1 by 2 and minus 1 by 5. So first we have to convert them to rational numbers with same denominator. Here 2, 5 LCM is 10. 2, 5 LCM is 10. So we have to make the denominator 10. 1 by 2 by multiplying with 5. 1 by 2 by multiplying with 5. Minus 1 into 5 minus 5. 2 into 5 10. We can write like minus 5 by 10. 1 by 5 by multiplying with 2. By multiplying with 2, minus 1 into 2 minus 2. 5 into 2 10. Now minus 2 by 10 minus 5 by 10. Both are having denominator 10. Numerator minus 2 minus 5. Now we can write minus 5 minus 5 by 10 minus 2 by 10. In between, what we can write? Between minus, because here 10 10, denominator is same. Numerator minus 5, numerator minus 2. Between minus 5 and minus 2, what another integers may come? Minus 4 by 10. So minus 4 minus 3. What rational numbers may come? Minus 4 by 10, minus 3 by 10. Like that, we can insert two rational numbers. At least, just by guessing, two numbers we can tell. Minus 4 by 10 and minus 3 by 10. Suppose this minus 1 by 5 or minus 1 by 2, instead of denominator 10, if we multiply with 4, here minus 4 by 20. Minus 4 by 20. Here if you multiply with 10, minus 10 by 20. Now they have been written as rational numbers with same denominator 20. So minus 10 by 20, minus 4 by 20. So between minus 10 by 20, minus 4 by 20, denominator 20 is same. What other rational numbers we can write? Minus 10 after minus 9 by 20, minus 8 by 20, minus 7 by 20, minus 5 by 20. Like that, we can write four rational numbers if we change the denominator. These four also exist between same, the given two rational numbers. So if you take the denominator as 30, 40, 50, 100, 150, by changing the common denominator, you can insert as many rational numbers between minus 1 by 2 and minus 1 by 5. That's why we have to conclude between any two rational numbers, we can insert unlimited number of rational numbers. Okay. Next challenge. So, example. List three rational numbers between minus 3 and minus 2. There may be unlimited rational numbers, children, but in the question they are asking only three rational numbers. So we have to find only three. Three rational numbers between minus 3 and minus 2. Minus 3 and minus 2. So minus 3 can be written as minus 3 by 1 because minus 3 is an integer. As a rational number, it can be written as minus 3 by 1. Minus 2 also can be written as minus 2 by 1. So minus 3 by 1 by multiplying with 5. Minus 15 by 5. Minus 2 by 1 by multiplying with 5. Minus 10 by 5. Like that we can write. So minus 15 by 5. Minus 10 by 5. What are the in-between rational numbers? Minus 14 by 5. Minus 13 by 5. Minus 12 by 5. Minus 11 by 5. So, but this minus 15 by 5 equals to minus 3. Minus 10 by 5 equals to minus 2. So, these are the rational numbers which are in between minus 3 and minus 2. Now we have got 4. They asked 3. Out of 4, any 3 we can write. Any 3 we can write. Okay, children. So what we have learned in this chapter, children, let's revise the summary of key facts. A number of the form P by Q, where P by Q are positive integers, is called a fractional number. If P by Q are positive integers, then it is called as a fractional number. A number of the form P by Q, where P by Q are just integers, may be positive or negative, and denominator Q is not equal to 0, then it is a rational number. Means in rational numbers, we can have negative integers also, but in fractional numbers, not. So every fractional number is a rational number, but every rational number need not be a fractional number. So every integer is a rational number, but rational number need not be an integer. Minus 5 is an integer, can be written as minus 5 by 1. So every integer is a rational number. But rational number 3 by 7 cannot be written as integer. So every fractional number is a rational number, because 6 by 7 is a fractional number, also a rational number. But 6 by minus 7 is a rational number, but not a fractional number. So P by Q is said to be in standard form if the denominator Q is positive and PQ have no common divisor other than 1, means they are coprimes, means their HCF is 1. So if a rational number is in standard form, we can also say that it is in lowest form, which cannot be divided further. Suppose if P by Q is a rational number and M is a non-zero integer, then P by Q can be written as P into M, Q into M, like that. With same number we can multiply. Minus 7 by minus 8 is there. With same number minus 1 by minus 1 we can multiply. Its value does not changes. Suppose 5 by 7 is there. With same number 3 we can multiply. 15 by 21 equal to 5 by 7. 8 by minus 19 is there. We can multiply with minus 1 minus 1. Not only multiplication, if P by Q is a rational number, M is a common divisor of P and Q, then we can divide with M also. We can divide with M also. 8 by 10 equals to 8 divided by 2, 10 divided by 2, which is equal to 4 by 5. Both of them are equivalent. 36 by 54, common divisor is 18. 36 by 18, 54 by 18, 2 by 3. Next one, if P by Q and R by S are two rational numbers with Q and S positive, denominator is positive, so then this cross multiplication S into P equal to Q into R. The sum of S into P means first numerator, second denominator equals to second numerator into first denominator. If it is greater than R by S, if P by Q is greater than R by S, same. First product is greater than second product. If it is less than second rational number, first product is less than second product. Like this cross multiplication. Next one, if there are two rational numbers with common denominator, like this, 8 by 17, 5 by 17, then one with larger numerator larger than the other. If they have common denominator, then numerator is large means that will be largest. 8 by 5 is greater than 5 because 8 is greater than 5. Minus 3 by 7, minus 3 by 19 is greater than minus 7 by 19. Why means common denominator minus 3 is greater than minus 7 because in negative integers lesser value will be greater. So every positive rational number is greater than 0. Every negative rational number is less than 0. Every rational number can be represented on a number line. Can be represented on a number line. For each rational number x, one of the following relation must be true. Only one. Exactly one of the following relation must be true. If there is a rational number x, it can be greater than 0. It can be equal to 0. It can be less than 0. If there are two rational numbers, first one may be greater than second number. First one may be equal to second one. First one may be less than second one. So the absolute value of rational number is always greater than or equal to itself, because absolute value of positive rational number equal to positive, negative rational number equal to negative. So negative rational number equal to positive means the modulus value is greater than the taken value. So absolute value is always greater than or equal to number itself. Next children, some fill in the blanks children. If the integers p and q have no common divisor other than 1 and q is positive, then the rational number p by q is said to be in standard form. It will be said to be in standard form or lowest form. Standard form or lowest form. So minus 5 by 7 whole power minus 1. When we have whole power minus 1, we can just reverse the digits, numerator and denominator. We can keep minus for the numerator and whole power 1 we can write. Modulus of minus 3 by 7 plus minus 2 by 7. First we have to add common denominator. Minus 3 minus 2 minus 5 by 7. Now we have to take modulus, which is equal to 5 by 7. Next, modulus of minus 3 by 7. So this is 5 by 7. Modulus of minus 3 by 7 equals to 3 by 7. Modulus of minus 2 by 7 equals to 2 by 7, whose sum is equal to 5 by 7. So left side 5 by 7, right side 5 by 7, both of them are equal. So dash minus minus 3 by 7 equals to 0. Here minus into minus, plus is there. It is plus 3 by 7. For its cancellation, we should have opposite. It's additive inverse. Minus 3 by 7, minus of minus 3 by 7. So minus 3 by 7, minus into minus plus 3 by 7, both cancel, result will be 0. X minus y equal to x plus of minus 5, because subtraction is an inverse addition. Subtraction is an inverse addition. If we write plus in the place of minus, then this additive inverse of y to be taken, minus y. Next one, true or false. So every integer is a rational number? True. Any rational number n you can take, just by keeping by 1, you can make it a rational number. The sum of two rational numbers, so first one is true children. The sum of two rational numbers a by b and c by d is a by a plus c by b plus d. It is not true children, it's false. This is possible when the denominators are common. In all cases, it's not possible. We have to take the LCM and we have to add. So 1 is the only rational number which is its own reciprocal. Its own reciprocal. Yes, children, true. 1 will have its own reciprocal. Because 1 means 1 by 1. Its reciprocal also 1 by 1. So if you take minus 1, we can write it as minus 1 by 1, whose reciprocal is 1 by minus 1. It is not possible to insert 10,000 rational numbers between 1 and 2. 1 and 2. They are telling not possible. Wrong children. Because between 1 and 2 we can insert infinite. Not 10,000. More than 10,000 also we can keep. Next, minus 5 by 7 less than 4 by minus 7. So, minus 5 by 7, 4 by minus 7, numerator we will keep up, minus 4 by 7. Now, denominators are same. Minus 5 is less than minus 4. Yes, true. Next, multiple choice questions. Every integer is a rational number with a denominator 1. With a denominator 1. 51 by minus 85 in standard form can be written as, because 51 by minus 85, minus we have to keep up, that is 1, divisible by 3 or divisible by 17. 17 3 times, 17 5 times. So, minus 3 by 5, because standard form means minus should be denominator to be positive and no common divisor, because they have common divisor 17. After division with 17, answer is minus 3 by 5. Multiplicative inverse of 0 by minus 5. 0 by minus 5. Actually, minus 5 by 0 we have to write. But if you have by 0, then that is not defined. That is not defined. So that's why let's go with the option not defined. So which of the following cannot be written as a rational number with a numerator 6? With a numerator 6. Which of the following cannot be written as a rational number with the numerator 6? So 1 into 6, 8 into 6, we can get 6. 3 into 2, 5 into 2. If you multiply with 2, in the numerator part we will get 6. 4 into 1, 11 into 1. In the numerator part we will get 6. But 4 into 1, 4 into 2, 4 into 3. If we take any number, we can take any number, but we won't get 6 in the numerator part. So, D option is the correct answer. By what rational number this number to be multiplied so as to get product 28 by 33? By what number 7 by 11 to be multiplied to get the product 28 by 33? We need x. Right hand side we have 28 by 33. This 7 by 11, if it goes to left hand side, it will become reverse. Minus we can keep up, it will become its reciprocal. 7 4 times 33, 28, 11 3 times 33. Minus 4 by 3. B option is the correct answer. Okay, children. Please visit our website, children, for www.aimstoday.in for previous recorded online classes, quizzes, live worksheets, do it yourself activities, English classes, coding classes, and remaining other things. So thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.